So today we will be starting something called oblique projectile motion. So in case of horizontal projectile, we we had thrown horizontally. The initial velocity vector was parallel to the surface of Earth, you can say. So now in this case, we will be throwing not parallel to Earth surface, either up or down. So in oblique, there are multiple cases. So the first case is throwing from the same like leveled ground. So you throw from the level and it bounces and it goes back to the same level. So same level, you can say leveled ground. In some book, they also use the terminology same azimuth, that has come from the word azimuthal, which is like some sort of orientation. So this is the first variety of question in which we throw at some angle, but on a leveled surface. So wherever it starts, it lands back to the same level. The idea is level. So the other two varieties that you will encounter in oblique projectile is like if you have a different level. So you throw from some angle, it may land here. This is also oblique. You may land on some height h. And the third variety is exactly opposite of the second. So in this case, you throw something and it goes like this. So these are the possible variety of motion of a projectile. So you may land on the same level, you may land up the level, you may land down the level. Now we can obviously understand if the angle is same in each case and if the initial velocity is also same. So what will differ is the time. So we can see that the time will be least for the case number, you can say maybe 2. So in various cases, the time will change. So 2 and 3 seems to be different because the angle of projections, okay, are not the same. Like, angle of projection is same, but the level at which they are landing is having different velocity. So they will differ in time, and they will differ in various other properties also. So these are the three varieties, and the same thing we also learn as something called inclined plane projectile. We just put into the different category for no reason, but that could be a possible case of uh, oblique also, and that could be a possible case of horizontal projectile also. So we'll see it later on. So now we have to deal with all these three varieties, and we will start with the first variety, So the first variety we will discuss at length, and using those concepts we will try to solve the second and the third case as well. So what is oblique projectile is obvious. In this case, you throw at an angle with whirlwind. Okay, so let's go to the derivation part. Now every projectile will have some very regular derivations, and these derivations are well known. So the first thing is like we'll take the case called oblique projectile on leveled surface. So we talk about the oblique projectile on the leveled surface. So let me do the surface first. So now you have a projectile which you throw at some angle. So when you throw something, then it will have some initial velocity. Let's call it V0. And it will have some angle of projection. Let's call it theta. So its subsequent motion will be something like this. We always take the case just before hitting the ground. Okay, just after leaving the ground. So now, because it's a leveled projectile motion, it is good to choose some coordinate system for the sake of writing the expression or mathematical equation. So the obvious choice that we can make here is taking the surface itself as the x-axis and perpendicular as y-axis. So we all know gravity is acting downward. So as usual, we'll try to write the components of initial velocity and acceleration as per the chosen coordinate system. So what are the four values that we tend to write always? Ux, uy.
AX.
So this is how we start with solving any numerical related to projectile. So what is ux here?
It's V not cos theta.
What is uy here?
V not sin theta.
And similarly, what is ax
C
and what is ay?
minus C.
Very good. So now we know our components, and therefore we are good to go with all the kinematical equation in these two mutually perpendicular directions. So the first question is obvious, and that is find time of flight. So what will be the value of time of flight? So what we use for the time of flight? Like you can see the entire journey, and what you can figure it out, like which variable is known to you.
V square is equal to V square. Yes.
So you are looking for
अच्छा हाँ
time
time.
time of flight. So you know
So
the
first equation.
y coordinate. No, okay. When you if you want to use the first equation, then what is the v y and uy? Uy, you know what is vy? Okay, so the better way of doing is at the end of journey, what is the y coordinate?
0.
And at the beginning of journey, what was the y coordinate?
0.
So we always use the displacement method, which is the first way to solve. So the delta y for the journey is how much? 0. So the obvious way to solve will be using the relation y minus y naught equals to. And why are we using this relation? For the obvious reason that we know the y value, the y coordinate, and we are looking for time of flight. Now, using any other equation needs some other variable which we need to evaluate from the given situation and then solve the question. So, if you look in the y direction, the obvious thing you can see is that displacement is 0. In the x direction, we have some displacement, so we don't know how much is that. Let's call it r, and even that is what we are going to calculate. Okay, so moving forward, let's substitute value 0 minus 0, v naught sine theta into t plus half minus g into t square. And then solving this is pretty easy. If you get the
2
answer
v
2
naught
v,
sine theta by g.
correct. So now we have time of flight. So the next question will be obviously range.
So V naught sine theta into T.
Yeah, v naught sine theta.
Cos
So
theta.
what is range actually? Range
Oh,
is the
sorry, V naught cos theta. Sorry, UX. Okay.
so what is range? Range is the displacement along the x direction during one time of flight, right? So range is the displacement along horizontal direction during one time of flight. Okay. So R is equals to basically x minus x naught. The formula is uxt plus half. But luckily there is no acceleration along the x-axis, so this term is 0. So this always turns out to be ux into t only. And because we're talking about the one time flight, so this is actually ux into t. So for the overall time period, the net horizontal displacement is this. So we should remember like this. Now this formula we can also see in various other forms like component form. So what is this? Isn't it this is 2 uy by g? Can you see that? So what you are writing is this only, right? So time of flight we always write as the 2 uy by g, which means it depends only on the y component. So t is 2 uy by g. And what is r? ux into t. So the one way of looking at the answer for R is ux into 2uy by g. This is how we look at the answer in component form. Which means if you know the x and y component of any oblique projectile motion, you can find the range easily. So they may not give you v naught. If they give you the component also, you can find the answer. And this method is why it is important, because this does not need theta. You can directly take the product of component and divide by g. So the other way of writing is how much? In terms of theta. So every formula of oblique projectile we prefer writing in two ways. One is called the component method of expression and expressing in terms of components. Another is in terms of absolute values called v naught and theta. So now we have a range as a formula 2ux and this will become 2 v naught cos theta and the other is v naught sin theta by g, and which turns out to be a very simple expression like this. Now both the expressions are equally important, so we cannot say that okay, this one is more like useful in the solving problem than this. So all will have their role to play in different cases. Now this formula is pretty interesting actually, and why I'm saying it's interesting because it tells you when the range will be maximum. For R max, how one must throw the object, at what angle you must throw to maximize the R. So we can say that for R max, the only possible way is making sine 2 theta equals to 1. Why? Because the ability with which you can throw something is fixed. So let's say you are capable of throwing some object with velocity v naught. Now, if you want to attain the maximum range, you must throw at an angle which makes sine 2 theta equals to 1, which means 2 theta is 90 degree and so theta is. So the obvious answer is that when both the components are equal, the other way of looking at it is when ux equals to uy. So for range to be maximum, the product of two number is like maximum, and it turns out to be that this is possible when the both numbers are equal. So at a maximum, or you can say for maximum range, one must keep the angle of projection 45 degree, and the maximum range that you can attain will be only v naught square by g. So you cannot go beyond this, which means if someone's ability is to throw something with v naught, then the maximum range you can think is v naught square by g. And this is having a very interesting consequence. So what is this interesting consequence? So imagine some Talibani takes a gun and start firing in random direction. So we know that the bullet coming out of a gun will have constant velocity v naught. So each bullet will come out with the same speed, no matter how you fire the gun. So bullets are going all over the places. Some bullet is falling here, some bullet is going near the edge. So now you can see that the bullet is going all over the place. But we know that no bullet can go beyond a certain range. So there is an upper limit up to which the bullet can reach out. So let's call this as the R max. Now R max is the maximum possible range where the bullet can go, and any person standing beyond this area will be in the safe zone. And this is the so now we can obviously say what is the area of the danger zone. Tell me what is the area of danger
So
zone.
is that a circle?
So pi into v not raised to 4 by g square.
Correct. So it is pi r max whole square. Yeah, of course it's a circle. Everything will fall on the ground, so it's a circular patch on which things are in danger. So of course the answer is pi v naught square by g whole square, and it turns out to be v naught power 4 by g. So if you are in this area, you are probably in danger area because you may bite a bullet. But if you cross this area, then bullet cannot reach out to you no matter what. So now that also gives you the idea that if I know like my enemies are carrying these grenades or bullets, okay, then where we should let's say if I'm the attacker or maybe some other invader, so where we must make our camp safer. So our camp must be, you know, much far from the danger zone. So let's say if you have a rifle and I know you the bullet can come out of the rifle with a speed of 500 meter per second. So I exactly know that how far I can go. So it will be like the maximum range is how much? It's 500 square by g. So this turns out to be, let's take g as 10 for solving. It's a 25 kilometer. So roughly up to 25 kilometer you're in danger zone. So you will try to keep your camp or the military away by this value minimum. So you may take for safety purpose 30 kilometer or maybe 40 kilometer, and then you will start the war. Okay, so these calculations are very, very important. In fact, the entire concept of projectile was developed by mathematician to fight a war into the French emperor called Napoleon Bonaparte. So these were the mathematics developed actually at that time. The mathematics of artilleries, the cannon, and it was actually meant for war only. Now today we are learning as a syllabus of JE or any engineering entrance test. But it was some work of the genius in the era of Napoleon Bonaparte. Okay, so these are generating from the French. Oh, I think Napoleon was French, right? Maybe I don't know.
Yes.
Yeah, so
Yeah, he was French. Okay, so what you're learning is the French history in physics. That's nice, right? You're learning the history through physics. Okay. So you know why India becomes slave to the Britishers, and the interesting story goes like this. So it was the second law of thermodynamics which made us slave actually. Okay, I will explain you sometime after when I'm teaching you P10 thermodynamics. So there is a very beautiful history behind every physics. Okay. So the very basic which you are going to learn very soon called Newton's laws of motion, and there is something called atom machine. So these things were the first like one of the mechanical way of punishing someone. So again, there is a history behind this. That's all belong to the Europe. Okay, so we got the few idea. We got what is time of flight. We got what is range. So what are the other things that is obvious in calculation? So that is called the maximum height calculation. So now the next is calculation of maximum height called H max. And when we throw something at some angle, so in this particular case, the component of the projectile which is V naught cos theta, this will never help you in going up, right? So what will help you in going up?
V naught sin theta, which is Uy.
Yeah, exactly. So it is the Vy which is going to take you upward, and therefore your journey, your upward journey will continue till the time this term becomes zero. So the maximum height is the height at which the Vy becomes zero. So what we say, it is the height at which the vertical component of velocity becomes zero. Now the horizontal will remain unaffected because of the obvious reason we know that there is no acceleration in the horizontal. So this component called V naught cos theta is always intact. So maximum height is not the height at which in uh, this particular case, that it is not the height at which the velocity is zero. No, velocity is there, and velocity is exactly equals to ux because that is constant all the time. Now the Vy becomes zero. Okay. So going by the definition, which formula we should use?
So V is equal to F. So time is given.
It is the height at which vertical,
Sir, V square equals to U square plus 2as.
so it is the height at which vertical component of velocity becomes zero. So tell me, the formula you're using is Vy square equals to this plus 2ay into y minus y naught. So you're calling this as origin. So Vy is 0, we know. Uy we know is V naught sin theta whole square plus ay is how much? Minus g, and what is y? So the final position is the h max and y naught is 0. So this gives us a very nice and simple formula. H max equals to V naught square sin square theta by 2g. Or the other way of looking at it is Uy by 2. Okay. So what we need to also realize that when we are writing these formulas, then we also need to realize that this the dependency and the component, like in on which component the particular answer depends. And what we can see that H max has to do with y component only. So if you are throwing various projectile with a different speed and at different angles such that the y component turns out to be same, then in all case they will have same maximum height. And we have also seen previously that they have time of flight is also function of only y component. So this is very important result actually, and it will help you in answering some of the theoretical question. So let me show you something very interesting question. It's a see the roof and this is the floor, and I'm throwing some object. So one is going this way, touching the ceiling and almost touching ceiling and coming back, and another is going this way. You can see very far. And the other is landing very far. So let's say the first is taking time of flight is t1, second is taking the. So which will take more time to reach the ground? So which one
So
will take
time
more time to?
to
Now that's like very obvious answer, right? But what is fascinating here is that the T1 and T2 both are same. So going farther will not reflect the time of flight. What reflects is the vertically how much it is going, because the time of flight depends on y component. So we know that T is 2uy by g. But we also know that h max is also uy whole square by 2g. Now these two will tell you something interesting. What it says, if they have same h max, so they must have the same y component because they have been taken by the y component up to that height, right? So y component for both the object must be equal. It cannot be different, in fact, because if you think that y components are different, then they will travel more height than the other. One or the other will travel different. So when you say that they have same maximum height, so it is understood that they have same y component. And if the y components are same, then definitely time of flight will be same, isn't it? Understood? So the going forward is because of the x component. So they have different x component. You can say ui dash and ui are equal, but ux dash and ux dash are not equal. So in the same duration, one is traveling farther, other is traveling lesser. So it is because of the difference of the ux actually. Understood? So you need to understand these concepts. So y component is responsible for two things. One is the maximum height, other is the time of flight, and therefore we must look through the lens of y component about these variables. And going farther, if the range are different, so it is due to the ux value, not due to the ui. Okay. So range depends on both x and y, because if you remove the range from it was 2ux uy by g. So the different value of x will give you different range, although y is same. So in projectile motion, try to look at the things in component fashion. Things will be easier for you. So in fact, we can relate the time of flight and h max always for oblique projectile motion. So for the case we are discussing, so we know that the time of flight is 2 ui by g, and h max is ui square by 2g. So this implies if I square the time, I'll get 4u square by g square, or 8u square by 2g square, or 8 by g by 2g, and therefore it becomes 8 by g h max. So this leads to a formula that t square is 8h max by g, and therefore, so we have always this formula that at t equals to under root of 8h max by g. So if we know the maximum height, we can directly find the time of flight without actually doing any other calculation, or you can derive it in examination, or you can say h max is equals to 1/8 of gt square. So that's very interesting. Okay, so it is 1/8 of gt square. Okay, so this will also act as a like kind of formula, but I'm not okay insisting that emphasizing that one should remember, rather just learn the derivation. And if you know that okay they have a relation, so you can derive in future as well. Okay, so what else we can derive in the oblique projectile motion? The obvious question will be equation of trajectory. So if I give you the origin x and y axis defined this way, And if the origin is representing the point of projection, so origin becomes the point of projection. And if you're throwing with some speed v naught at an angle theta, so after some time t, it will be somewhere here with x coordinate and y coordinate. So can you find the x and y coordinate at time t? So the heading is equation of trajectory. So determine the x and y coordinate as a function of time t and tell me the answer.
Hello, sir.
Yes. Am I audible?
Yeah, I got this thing. So can you
Hello,
repeat
hello,
the
hello.
question?
Hello, hello. Am I audible, guys? Okay. So find the x and y coordinate as a function of time t. That's it. Can you do this?
Hello, sir.
Yes. Hello, hello, hello. Hello, 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 hello. Hello, 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 hello.
Sir, you are audible.
Am I audible now?
Yes, sir.
So I am asking find the x and y coordinate as a function of time t. Can you do it?
Yes, sir.
So go ahead and solve this question. Tell me the answer. Tell me the answer.
Sir, it's 2 into y into ux is equal to uh,
Mhm. No, just tell me what is x. First, you tell me what is x.
uxt.
Yeah,
Yes,
what is
UX.
what is ux?
V not cos theta.
V naught cos theta.
Okay, fine. So you got to x. What is y? Here y naught is 0. So you must be using this relation, right? So y minus 0 equals to uy 3 plus half. Okay, I should put in the answer. Y equals to how much? What is uy? V naught sin theta minus half gt square. Now you have the x and y in terms of given knowns. So these are the values
We
which
can
is known.
find.
So you are supposed to find the relationship between y versus x. And to do so, you need to eliminate the common variable called t. So can you eliminate the variable and tell me what is y equals to in terms of x?
Sir, y equals to tan theta minus half gx square by v naught cos theta the whole square.
Sir,
Okay.
it's x tan theta.
Yeah, correct. So the
Sorry,
answer
x and
yeah, it is x tan theta minus gx square upon 2u 2v naught square cos square theta. So this is the equation of y versus x, and you can see the coefficient of x square is negative, and therefore it is inverted parabola. And so we have actually inverted parabola. Now, can we find the range from this expression? Can we find the range from this expression?
yes,
Yes.
sir.
So now what we are going to do is we are going to do derivation using the equation of trajectory.
So I want to know.
You want the last page?
Yes.
Oh,
Done, sir.
okay. Okay. So now the next part is called derivations. using equation of trajectory. Now, through this exercise, you will be learning how to use quadratic equation. So there are two ways of looking at the expression. One as a equation of trajectory of oblique projectile motion. Other is just a basic mathematical quadratic equation. So let's develop various perspectives to look at this expression. So this is one way of writing. Now let's calculate let's calculate range. So let's calculate range. So what is range? It is the difference between the points or the x coordinate at which the y value is 0. So if you throw something, you can see that if you throw something, you can see that at the beginning y is 0, at the end y is 0. So if you put y equals to 0, it will give you two values of x. If you substitute y equals to 0, this implies x tan theta minus g x square and if you solve this expression, we can take x common, so it's tan theta minus gx upon 2 v naught square cos square theta. And if this is equal to 0, so either this is 0 or tan theta equals to gx upon. So we know definitely the second answer is the range itself, isn't it? So the x from the second expression turns out to be how much? So we call it a range equals to, let's call this as x1 no. So range is definitely equals to v naught square cos square theta into sin theta by cos theta, and this cancels out. So we are getting the answer which we already know, and it is not difficult. It is not. Okay, so can you find the maximum height using this formula? I think this should not be a difficult task. And how to go about it? Hello guys, are doing?
Yes, sir.
Okay. So what will you do to find the maximum height? Y is a function of x. So for y max, what we do in calculus?
Sir, derivation. With
Correct.
derivation is 0. So I
Yeah,
will do the same
derivative,
thing.
not derivation. Derivative is 0. The first derivative is 0. Yeah. So that's good. Go ahead. So that will give you the critical value that at which point it is going to happen, and then you can substitute. To make the calculation easier, I will tell you something how to proceed normally. So for h max, in this expression, you can write y equals to ax minus bx square, where a and b, you know what I mean. So a is tan theta, and b is definitely g upon. That will be easing out the effort of writing, and now solve from here. Once you get the answer, then substitute to the a and b backward. Okay. So do this.
So it's coming out x is equal to minus a upon 2. So
Pardon?
now, so it's coming that x is equal to minus a by 2.
How x can be negative? That's ridiculous. If you're differentiating and equating to 0, how you're going to get negative answer?
Sir, I got V naught square sine theta cos theta by G as x.
Where is b naught? I don't see any b naught.
Oh, okay, so that's minus.
I don't know what you guys are saying, what anything you're saying. Okay, you're saying v naught or b naught. I don't know.
Sir, V naught. so u that magnitude v naught.
Okay, V naught. Okay. So okay, so you are saying the answer. What is it? So you're getting the answer. If you differentiate and equal to 0, this will give you a minus 2bx equals to 0. So x is a by 2. So the y max, or you can say h max, is a multiplied by a by 2b into b into a by 2b whole square. A square by 2b minus a square by 4b, which turns out to be a square by 4b. That's the answer. H max is a square, which is tan square theta 4b 4g upon 2b naught square cos square. And this will give you v naught square sin square theta by 2. That's the answer. So we can calculate the H max and range from the equation of trajectory. In fact, this idea should also always be there. You will come across various questions in which they will give you some quadratic and ask you to find the various quantities like range and all. Understood? So this itself is a question from Eroda. This what we just solved. This is Eroda question. Done? Understood?
Sir, noting.
Okay. Okay. Next. So now we will see something more interesting from this equation. So this equation of trajectory we can also write in some other way, and the other way is more useful than writing in this particular way. So question is, can we write this in terms of range? So
Yes,
what,
sir.
yeah, what we are not looking for is the uh, V naught square and G. Like we want answer in terms of just range. So for range formula, we know range equals to V naught square sin 2 theta by G. So we can replace V naught square by the formula GR by sin 2 theta. So use 1 and 2 and tell me the answer in terms of range. Do it.
Sir, x will remain in the equation.
Yeah, yeah, X will remain because we want everything in terms of displacement actually. So the range is like a displacement, right?
Sir, the equation will be like x tan theta minus sine 2 theta x square by 2 r cos square theta.
Can you simplify this further in terms of tan theta, because the last term also becomes tan theta. So using 1 and 2, you can make it further simpler. So V naught square we can replace by GR by sin 2 theta into cos square theta, and
Sir, it's square by
okay. So we are going to get the very nice formula which is very helpful. So y becomes equals to x tan theta minus x square, and sin 2 theta we can write as 2 sin theta into cos theta,
2
right?
sin theta into cos.
You can see that this cos will cancel out, this 2 will cancel out, and what we have is sin by cos by sin, which will become exactly x tan theta minus x square tan theta by r. So the formula looks really nice if we take even common x tan theta. It becomes 1 minus x by r. That's simple. Now this formula is very useful. It is really useful actually. And this formula will give you something interesting. Why interesting? Because the y max and the range will have direct relation. You know how? Because we know that in oblique projectile motion, the y max happens at half of the range, right? So
Yes,
when y equals to h max, x must be r by 2, right?
yes,
So when the height is maximum, the range must be how much? X must be how much? R by 2. And if you substitute, what you get is h max. So I can say maybe question number 3. I just call it A. A implies h max equals to r by 2 tan theta 1 minus r by 2 by r. So we have a very nice relation between h max r by 2 tan theta into 1 by 2. And this gives a formula something called tan theta equals to 4h max by r. This is something very interesting. And this is a very powerful formula which solves question very quickly.
Sir,
Yes.
sir, why we took x is equal to r by 2 for h max?
Because of the symmetricity of the parabola. So if you are throwing some object, so the h max happens exactly in the middle point, right? So midpoint must be half of range.
Yeah, sir, understood.
So that is the reason. I hope this is not difficult.
Yeah, sir, understood.
Okay. All right. So we have tan theta equals to 4h max by, are there various ways of writing, or h max equals to r by 4 tan theta? Okay, so you can write it like this. This is famous answer. Now, what does it mean? If I know the range and if I know the angle of projection, so I can directly find the H max, isn't it?
Yes, sir.
So you may think this way. So let's say you want to throw something from here and you know exactly where it should land. So you know that it should land here. So it must land at a distance d, or you can call it anything. Let's call it d. Okay. So if you throw at an angle theta, and nothing is velocity is not given. What is given is angle is given and d is given. So there are two ways to solve. Either you solve from basic, like assume v naught, write the expression, and get the answer. But the other subtle way of doing this is directly use the formula. So we know that what is H max.
R by 4
So here R becomes d by 4.
D.
Okay. And it's simple, d by 4 and then tan theta. So that gives the direct answer. Or imagine the situation is something else. It's like, so there is a wall actually. There is a wall. So two friends are standing at the same distance from the wall. So let's say this is the wall and you are standing here and your friend is here. Exactly same distance, d and dr. And you want to throw a ball which just reaches your friend. So you must be throwing with the least effort. And if it is just reaching the friend by grazing the wall surface, maybe it's just going over the wall actually. So what is obvious here? So you know the H max, let's say the height of the wall is H. You know the H max, you know the range. So the question they will ask you that find the angle of projection to achieve the same. So you can directly say answer that tan theta equals to how much?
So theta equals tan inverse to H max.
Yeah. So for H max, which is H, by range, which is 2D, this turns out to be 2H by D in this case because I have taken D differently. Now that's very interesting. Like we can get questions like this, and what is interesting is how to approach in a faster way, quicker way. So in Projectile, this formulas plays a very vital role in solving many challenging problems. So you will come across problem and you can think of these formulas, then you realize how fast it is. Anyway, so what else we can do with equation of
So just
trajectory?
one question. Sir, in the last question I want now. Sir, if
Yeah.
like some subject is throwing the object with some height h, we just have to subtract that height h from the maximum.
Pardon?
Sir, if the ball is thrown by a subject from with a height h, then we have to just subtract that
Yes,
height
yes,
h
yes,
from the maximum.
yes, 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 yes. Correct. Yeah. Okay, so okay. So imagine the other application of this. So you're standing in front of a maybe that basketball, same thing. This is the net, and you know exactly that you are at a distance d from the net, basketball net, and this is capital H, and there is a player of 5 and he is trying to throw, and he just want to land the ball horizontally, like somewhere. It should reach here like this. So at what angle he must throw to throw the ball in the basket? So now what we can realize that if the ball is landing horizontally,
So then the Vy is equal to 0, so it is an H max.
exactly. So this means this is the H max. So the man is standing exactly half of the range. We can ignore the dimension of the basket. So we know the range actually. So we know two things. We know H max. So here H max is obviously H minus H, subtracting the height of the man. And the range is also 2D. So the at what angle you must throw is very much obvious from the expression. So we can directly get the answer 4 H max by range. Now imagine solving the same question by basic method. So it will take a lot of time. Of course, I mean, we have derived everything from basic. But knowing the formula always helps. That is the idea.
So why 2D?
Pardon?
So why did you take 2D?
Because the man is only halfway now. So what is the range? Man is at a distance deep from the wall, not from the other end, right? So this part we have to imagine. Understood?
Yes.
All right.
So I want to know this.
Yes.
Sir,
Hmm.
sir, like the point where the particle goes parallel or horizontal to the y plane or parallel to the x axis, then it is
Hmm.
H max. No,
Exactly, exactly. Whenever it is parallel to the horizontal, it is H max.
then so if it is parallel to the vertical, then
How it could be possible? Then you have to throw vertically only, no?
sir, in yeah, JEE mains that question came like parallel to vertical.
So if it is parallel to vertical, it means you are not throwing like this. You are throwing upward only, no? So parallel to vertical means you are throwing vertically. Then how is the ball will go vertical?
Notice.
Clear?
Yes, sir.
All right. So let's go to the next part. Let's do something nice. So what we have at our disposal is a very famous problem called hill problem. So you know what is hill problem? Like if we do any random projectile, this looks like this. So imagine this is a projectile. So inside every projectile, we can always draw. It's not nice. So imagine I'm drawing a triangle which is like a mountain. So what you're supposed to do is you're supposed to throw. This is a mountain. You can imagine this is some sort of mountain. So what you're supposed to do, you're supposed to throw an object which can just graze the vertices or the peak of the mountain. You should graze. So you should go something like this. So this is called angle of elevation of the mountain from the two ends. So if you look from the left end, this is the alpha is the angle of elevation. And if you look from the right end, the beta is the angle of elevation of the mountain. The elevation means the peak. Okay. So to look at the peak, how much you have to tilt your head. So alpha and beta are called the angle of elevation. This is a very standard practice to write. So alpha and beta are the angle of elevation. So now the hill is there. And now what they're asking is at what angle you must throw at what angle you must throw. Now this angle is theta actually. Let me do it. So that it goes like this. That's theta is the asking. And what is interesting here to learn that as long as the range is equal to the base of the mountain. So what we try to fix here is the range of the projectile must be equal to the base of the mountain. That is always there. So to achieve the same range, we can have various value of V naught and theta combination. So we know the range formula is so now what we know that if I to keep the R constant, we can vary V naught and theta in various ways. So there are infinite combination of V naught and theta, which can give you the same range, isn't it? So out of this infinite combination, there is one angle which can also go through the vertex of the mountain. So we are supposed to find that angle. Okay, understood?
Yes.
What I'm doing is I'm taking the base into two parts and I'm calling this as x1 and x2. So what we can see that this coordinate I know x1 comma h, right? So if I choose this as x-axis and if I choose this as origin and of course the vertical as y-axis. So we know one point coordinate of one point which is part of projectile also and it is also the vertex of the mountain. So which formula will give me the right answer? The answer is very simple. If you know the answer y equals to x tan theta, 1 minus x by r. This is a very standard answer, and that's why we all remember. So what we can see that at x equals to x1, y is h. So let's substitute the value. Y is h, x is x1. Tan theta we are trying to find the angle of projection. X1 by range. What is range here? So if you look at the range, it's very simple. It's
X1.
x2 plus. Yeah, right. So this turns out to be something really nice. And what we are looking for is tan theta. That is theta. So tan theta turns out to be x1 plus x2 into h upon. And if you look carefully, this will become h by x2 plus h by x1. If you multiply and divide by x1. And what is fascinating here is that these two values, h by x2 is tan beta, and this is tan beta. So now you know that the relation is obvious, tan theta equals to tan alpha plus tan beta. If you know the angle of elevation, so the tan of angle of elevation, that alpha and beta, is equals to the tan of angle of projection. So this is the relation that we can derive using this formula. Otherwise, thinking about this formula is very difficult. Now, was I genius to know this answer? The answer is no. I saw it first time. I saw the entire solution and then I realized, okay, this I can solve. So these are very standard problems, and do not bother about how much exactly you know. Okay, so no need to worry about the same. All right. Next. So tan theta is equal to tan alpha plus tan beta. So next, what we can do? So from the oblique, we have something more still left, and something really nice, and something really interesting also. So we will see what is nice, what is interesting. Okay. So let's go back to the formula of range. Now we're done with the part which is based on the equation of trajectory. So we will not delve deeper into the equation trajectory. That's good enough. So let's go to some new concept, some new interesting facts about the equation. So this is the formula for range. Now there's something really fascinating fact about oblique projectile, and that is you can achieve same range. So you can achieve same range with same speed at two different angles. This is interesting. So what a nice name. So maybe this is, yeah, this is okay. Okay. So what I'm saying is that you can see that let's say you are able to throw some projectile at some speed. So speed is fixed. Now what I'm saying is what is interesting here is that the same projectile can reach the same range for two different angles. So here V naught is same, range is same, but there are two possible angles. So now this is interesting. You can do so at two different angles. So let's call the first angle as alpha and other angle is beta. And what you can see clearly that they have different y component, they have different x component. So they have different maximum height. Now, if the maximum height is different, what does it mean?
So that
Their
my component
yeah, their y component must be different.
and X component was same because R
Yeah.
is
And because they have same range, so the x component it must be also different because the range depends on x and y both component, and if one is different, the other must be different. Okay. So yeah, so that is always there. So here there are two things which is known to us. I mean, they will not give you velocity or all. This is what I will assume. If they have different y components, so they must have different heights. So let's call h max as h1 for the alpha and h2 for the beta. And because they have different maximum heights, so we can also say they must have different time of flight. So they will have t1 and t. Now we have to prove that for which two angle they will have different. Sorry, they will have same range. So what is the relationship between alpha and beta? And it turns out to be very simple actually. So let me write down the formula like this: V naught square sine 2 alpha by g, and this is same as
V sine 2 beta.
Just okay. Yeah. This is V naught sine 2 beta.
Hello, sir.
Yeah.
Sir, I was not able to hear you after you wrote that the big one is H1 as the height. After that, what did you say?
Nothing. Nothing. Don't worry. So I said that in when we have different H max, so we must have different time of flight. And if the range is same, then the formula for range we can apply, right? Like this.
Yes.
Okay, that's it. This is what I'm saying. Nothing else. So we can write as V naught is probably will by G will cancel out. So what we have left with sine 2 alpha minus sine 2 beta equals to 0. Now we have to use the sine C minus sine D formula. I hope you remember,
Yes.
which is 2 cos C plus D by 2, so which is alpha plus beta into sine C minus D by 2. Now when the product of two variable is equal to 0, so one of them must be 0, right? So we can add cos or sine. And what we know that the other equation, the sine equation, will give you alpha equals to beta, which is of no sense because we are looking for different answer. But the first will give you something different. So if cos alpha plus beta is 0, it means the angle must be
90.
which means okay, this is my laptop hijacked like something else. Okay. So it means alpha plus beta is equals to 90 degree. So beta is 90 minus alpha or alpha is 90 minus beta, which means the angles are complementary angles. So what we say? So we can put as a note for complementary angle. For complementary angle, projectiles throw at same speed will have same range. But what will vary is the height and the time of flight. So now this is the property which you need to remember. We can put as a heading as same range. Yeah, let's put some heading just to recall it. So okay. So now what kind of question they will be asking you? They will not I mean give you V not and alpha beta. They will just tell you the fact that two projectiles are thrown with same speed in such a way that they have same range. So they will ask you find the ratio of their angle of projection. So there are three questions they will ask you: tan alpha by tan beta. They will ask you find the range, find the velocity of projection. No, not tan alpha. They will ask you tan alpha only. So you can find only any one angle because that's good enough, right? So find tan alpha or tan beta or uh, a range and V naught. Given that their maximum heights are h1 and h2 respectively. So the only thing which you know is h1 h2 and the fact that they have same range. Can you find these values?
Yes, sir.
Okay, so go ahead and try then also.
Sir, sir, I
Mhm.
got all the three answers.
You got the answer for range.
All three answers, sir.
Pardon?
Like, means I got all three answers. So should I say
Okay,
them?
all three. Yeah, tell me.
So V naught is under root 2g h1 by sine alpha.
No, there is nothing. Alpha, beta is not given. Everything you have to find actually. The only information is H1 is 2.
So then they have also not given that they're projected in beta and alpha.
No, nothing is given. Only information is given. So that's very easy. See, I will tell you how to solve. Don't worry. The method to solve is start with the given variables. So H1 is given. What is H1? H max for the first case. And the formula is B square by G. So H2 is how much? That's simple. Now, what we know is since beta is 90 minus alpha, so H2 we can rewrite as cos square beta by G. Uh, Cos square alpha by G because sin 90 minus theta becomes cos theta. And therefore, to find the V naught, we can directly add H1 H2. Why? The moment you add sin square cos square will vanish. That's the trick. So both becomes 1. And therefore, now we got the nothing. So we got V naught equals to under root just 2g h1 plus h2. Now see how easy it is. And because we know h1 h2 in terms of alpha, if we divide h1 h2, like what we are doing is addition. There are three operations which we do normally. We multiply, we divide, and we add. We don't subtract. So we do these three operations and we get very fancy. So if we divide h1 by h2, you will automatically get 10. So the 10 alpha turns out to be under root of, that is also done. And the last part is a bit tricky. That is called the product because you know, I mean, to find the range, you need v square sine 2 theta, which is like something like sin alpha, sin cos alpha. So let me tell you the hint. Take the product and simplify to get the range. Can I do that? So your job is to find the range, and the hint is take the product and try to rearrange things in terms of range. Can I do this?
So can you show the previous page?
So why tan square alpha equals to h1 by h2?
Or you take the ratio, you will get the answer. There is nothing like why. It is actually there in front of you. Can you see it? No. Okay. Look at this expression. Look at this expression. If you divide these two, what will you get? Tell me. If you
Yes, sir.
divide these two, what you get? So all will cancel out. Only sin square by cos square will be there, right? Done.
Sir, I'm getting right. H1, H2, root under H1, H2 is equal to V naught tan theta by 2G.
Okay. So I think this is very difficult for you guys. Okay, so no problem. Let me solve this. So the moment you multiply, you will get V naught square sine square alpha by 2G and V naught square sine square beta by 2G. And what I'm saying is convert into one angle like alpha only. So we know beta is 9 plus alpha, so this will become V naught square of will power 4 sine square alpha cos square alpha by 4G square. Basically, if you look at this is V naught square sine alpha cos alpha upon 2G whole square. Now you can pick up the answer quickly from here because we know that range is how much. What is range? You can add a range for anyone. Huh? This is the range. So V naught square and we can add a sine 2 alpha by 2, which becomes 4G. And this formula is nothing but the R by 4 whole square. So range is equals to 4 times root H1 H2. Okay. So yeah, for the first time it may be difficult, but if you practice, you will find it easier going forward. So now repeat the all same problem. Repeat the calculation if T1 and T2 are known. Instead H1 and H2. Because what I said is they will have different time of flight and they will have same range and same speed, but they will have different time of flight and different maximum height. So what if the T1 T2 is given to you and you're supposed to find tan alpha, V naught and R. So I hope this time you will get the idea. And there are three steps mostly. Some sort of addition, some sort of division, multiplication. So it's up to you to think and solve. Go ahead.
Sir,
Yes.
we can find out H1 and H2 by T1, that formula.
No,
where
no, no. You're not supposed to find H1, H2. You're just supposed to find the V naught, tan alpha, and R using T1, T2. That's it.
Directly.
Directly, of course. See, how you need to begin? You need to begin by writing the equation first, and then think of manipulation which can give you the answer. So if T1, T2 are given to you, so you start with T1, T2. Write their expression and think from there.
So tan alpha is taken upon T2.
Yeah, right. Very good.
Sir, for R equals to T1, T2 by 4.
Pardon?
R equals to T1, T2 by 4.
No, that's not right.
Sorry, sir, T1, T2 by 2 it is.
No, that's not right.
So why it is like, because I'm getting the same answer as both the side.
You're doing missing something. Try once again. Try once again. You get the answer.
Sir, is it G T1 T2 by
By once again.
G T1, T2 by 2.
Yeah, that's the right answer. It is G T1 T2 by 2.
hello, sir?
Very yeah. Yes,
Hello,
yes,
sir.
yes. Yes, yes, I'm listening.
Sir, I got G T1 T2 by 2.
Hello. Yeah, tell me once again.
Sir, I got G T1 T2 by 2.
Yeah, that's the right answer. So that is the answer for what? Range.
Yeah, sir.
Yeah.
Sir,
So
range.
tan alpha is 1 by 2. That's easy. And range is G T1 T2 by 2. That's also correct. What about the V naught? This is also
So
easy.
finding. So
Yeah,
finding that.
fine, fine.
Sir, I got your g times t1 plus t2 divided by 2 sine 12.
बेटा साइन नहीं आएगा ना, कहाँ से तुम लोग कैसे बुलाते हो? तुम्हारा आंसर क्या होना चाहिए? योर आंसर मस्ट बी ओनली इन टर्म्स ऑफ t22. So why you are thinking not in that way? See, it's very easy. So when you write the formula, t1 is how much? Tell me. What is t1? Tell me.
Sir, it's 2. Sir, 2 v naught sine alpha by g.
So can I write t2 equals to 2v naught cos alpha by g? Because we know beta will be 90 minus alpha. And whenever I have sine and cos, how to get rid of sine and cos? What we do to get rid of these two? Square and add. So t1 square plus t2 square. If you, the moment you square, you'll get 4v naught whole square by g square. In fact, you can say 2v naught by g whole square. So we got the answer. So v naught is how much? G by 2 under root of t1 square plus t2. So these are some basic manipulation skills one should have. The moment I see sine cos, I know what to do. And we have done this quite often in the finding the equation of trajectory also. So for every question, you need to have a separate theory. Apply what you have learned so far. So the idea was to eliminate, and this is how we can eliminate. Okay. Okay, so we are done with the oblique projectile, and I just put something miscellaneous, like which is a very traditional thing called velocity analysis and so on. So for any projectile motion, finding the velocity versus time relation is very easy. So we have done this already. So if you throw with velocity v naught angle theta, so it will have like constant horizontal component, so that remains always fixed. V naught cos theta. And vertical component will change. And how much? So after some time t, it becomes v naught sin theta minus gt. We know all this, right? And then at maximum height it becomes 0 because gt exactly becomes equals to v naught sin theta, and that we call time of ascent. So at this point vy becomes 0, and if you solve, you will get the answer. Again, while coming back, if you come back to the same level, the v naught will be on the right side, but the downward will be exactly the same. But this time the gt is bigger than v naught sin theta. So these two are actually equal in magnitude. So v naught minus v naught sin theta minus gt right now is same as gt minus v naught sin theta, and they are always equal. And therefore, this angle, if we do the exact v some value which we don't know, this will be also v. And this angle, if I say alpha, this will be also alpha. So once it will be above the x-axis and other will be below the x-axis while descending. So these are something called velocity analysis. And in oblique projectile motion, we have two possible angles for same level actually. So at one particular height, you can trace two angles, once while ascending, other while descending. So as I said, velocity vector we write as Vx I cap plus Vy j cap. That's a traditional way. And then just substitute the formula. So it's V naught cos theta I cap, because there is nothing, there is no acceleration, but this will be V naught sin theta minus Gt j cap. So tan alpha we write as Vy by Vx plus minus. Why I'm writing plus minus? Because this can happen twice. So while ascending and while descending. So yeah. So plus minus Vy is how much? V naught sin theta. So let's say you cross this point at t equals to t1 and this point at t equals to t2. So if I want to use t1, can I write tan alpha equals to v naught sine theta minus gt1 by v naught cos theta, because at the first point you are ascending. So at t1, because you are ascending, so I can take plus value. And at t equals to t2, I must write v naught sine theta minus v naught sine theta minus gt2, because this is exceeding this value, upon v naught cos theta, which automatically becomes gt2 minus v naught sin theta upon v naught cos theta. And these two questions will help you in getting the difference of time, like when you cross the same level at two different instants. So we are normally both, I mean, interested in finding the uh, t1 and t2. Let's say alpha is given. So if I say velocity vector makes an angle alpha with horizontal, I'm not saying up or down. So there are two possibilities. So what is the difference of time? So this turns out to be a really nice expression. And in the from the first expression, you can say v naught sine theta minus gt1 equals to v naught cos theta into tan alpha, and yeah, and we have what next? V naught, yeah. So gt2 minus v naught sine theta equals to v naught cos theta into tan alpha. It's the same expression. And what we're looking for is t2 minus t1. So what we can do is you can just add this. And if you add anything along, all okay? Yeah. If you add, what we get, we're going to get, this will cancel out. So what we get is g t2 minus t1, and it's 2 times v naught cos theta into tan alpha. So the difference of time when you will be crossing the same point. All right. So okay, these kind of questions are also there. Okay, they may ask
Sir, I
you.
want to note this.
Okay, so they may ask you find the t1 also. What is t1? Can you solve for t1 only t1, not t1? So you can solve from here. You can get t1, you can get t2. So you can find t1, t2 also. So at what time you will be at angle alpha, or you can say after what time the velocity vector makes an angle alpha, although you have thrown with angle theta. So theta will change, the angle of velocity vector with horizontal will change with time. So at some instant it is alpha. So they may ask you find the alpha. Find the t1 actually.
So what do you have to find?
T1, T2. See, the rest of the analysis will be same. Whether it's velocity analysis, displacement triangle, V triangle, I have discussed all of these, right? So now it's up to you to apply those concepts. In fact, I have also discussed in the vector chapter. So what I will suggest you that you just try on your own the two parts called the velocity triangle and displacement triangle. So I will not give you everything, shoved on the plate. So the idea is there are certain things which you need to explore actually. So now you have lots of questions. You will get in tutorial also in homework. And now rest of things you need to explore with your own hard work. So in this way, I can keep on giving you content. This is like endless thing. So projectile motion is something like endless scope. You have infinite things to think, do, and so on. Okay. So all right. So I will be ending the oblique here, and our next lecture will be based on inclined plane projectile. So we'll see something very the difficult one. So before you come for the difficult part, try to practice the easier part. So the next class is going to be really challenging.
So can you show the previous slide?
Okay.
So one.
Sir,
Okay. Hmm. Tell me.
uh, sir, the like we have to find the T1 and T2 for like for general values like
Yeah, yeah.
formula.
T1 means like you throw at 0. So after what time the angle becomes alpha? That's the meaning of T1. And T2 means again after what time angle becomes, this is T2. So T1, T2 are from beginning, right? So since you project the projectile, after what time the velocity vector makes an angle alpha, and the rest of things are very simple. Like
Sir, this is also like that symmetricity concept.
yes. So here
Noted.
again, there are many ways actually. You need to explore. I mean, if I give you everything, then you will be totally handicapped. So I'm not trying to give you everything. So you can solve for time of ascent. What is time of ascent? Time to go from here to here. So I'm giving you homework. Find time of ascent, time of descent. Uh, Solve using velocity triangle, displacement triangle, and so on. So these are things which you need to explore. Okay, explore and see what else you can go through and see through it. Okay, all right. So let me end lecture here. Any doubt?
No, sir, no doubt.
No.
Okay. Bye and take care.